In this lesson, you guys will be able to apply the properties of rectangles. Now, doesn't that sound exciting? First, why don't we write down some properties about rectangles that are a little different from our parallelograms. First off, all the same properties from a parallelogram exist in a rectangle. However, there are a couple more. First off, our diagonals are congruent. And also, we have 4 right angles. Those are the only differences from being a parallelogram to becoming a rectangle. Congruent diagonals and 4 right angles. But we can also say any one of our properties from parallelogram will also exist in a rectangle. So we can use all those properties in our proofs. And I know you guys love proofs. And look at that. We've got a proof right here for you guys to try. Yes, I am so excited. Now it says we want to prove that the diagonals of a rectangle are congruent. So basically we're given that we have a rectangle. We want to prove that those diagonals are going to be congruent. So any of our properties are going to exist for a rectangle except for the fact that the diagonals are congruent, because that's what we're trying to prove. So why don't we draw out a rectangle first? So our given is rectangle ABCD. That's what we're told, it's a rectangle. But what we're trying to prove is that AC is congruent to BD. There we go. And now we can get going on our proof. Let's try to get a game plan here. I want to prove that my 2 diagonals are congruent. Alright, well, let's think maybe triangles first. So a lot of times we can prove triangles congruent, and then we can get some sides or angles to be congruent. So that's a possibility. Alright, so if I want to prove that these 2 diagonals are congruent, I have to have triangles that share those diagonals. Alright, well, I could think about maybe like this one here, this one here, something maybe that shares a side. Well, let's see here. If I go with this triangle here, and then, let's see here, how about this triangle right here? These both have the diagonals that I want to prove congruent. They do. Okay, so that's number 1. Number 2, do we have like a shared side so that we can prove congruent? Absolutely. Look at that. We got a reflexive side right there. Also, remember, we know that opposite sides are congruent in a rectangle, so these 2 are congruent. And what else do we have? We have 4 right angles. So we have a right angle right here, and then we have a right angle over here in the green triangle. And I know that right angles are congruent. So what do I have here? Side, then angle, and side. Side, angle, and side. Excellent. So I am all set to go here with this proof. Let's write it out. So for our first one, how about we write something like A, B, and CD are congruent by opposite sides in a rectangle are congruent. Make sure you put this first part here. If it's a rectangle, then the opposite sides are congruent. Don't just say opposite sides congruent. Make sure you put that if it's a rectangle. So you're telling me like what quadrilateral it is. That way I know which properties you're using. Next one, we have a reflexive. So I have 2 of my sides. I still need my angle in there. Well, I got my right angles. So angle ABC and angle DCB are right angles. And I've got my property written down there. In a rectangle, we have 4 right angles. And what do we know about right angles? Well, they're congruent. Oh man, we are getting close here. I can smell that proof. It's so close, and it smells glorious. Well, I've got enough to prove my triangle's congruent by side, angle, side, so why don't we do that? And lastly, the glorious, glorious proof statement, and I'm done. So we've got side or segment AC is congruent to segment BD by CP, CT, C. And sometimes I forget what that stands for. Actually, no, I don't. I always got to remember that. Corresponding parts of congruent triangles are congruent. Whew, I love that. We talk about that at Thanksgiving dinner. And, just when I wake up, I'm like, CPCTC, yo, what up? So there we go. We prove our triangles congruent in this rectangle, and then we're able to prove that our diagonals are congruent. Boom, now we can use that anytime we want. We can say, yo, I got congruent diagonals here because I'm awesome. This next one is not a proof. Ooh, good thing, because we only have to find AD. So let's see what we're given here, though, because the given information is important. We've got circle O, so this is a circle. Oh yeah, what do we know about circles? All radii are congruent, that's right, we always remember that. It says that OACD is a rectangle, so this guy, OACD, is a rectangle. Notice how when we name it, it's either going counterclockwise or clockwise. We're not jumping all over the place and doing whatever. We're going in order, so always remember to do that. And I'm told that OA is 5, so this segment is 5, and AB is dose. Lovely. Okay, and it's asking me to find out what AD is. It's asking me to find that diagonal. Well, what do we know about diagonals in a rectangle? I know that diagonals are congruent. So let's see here. If I were to draw this one in, I would know that OC and AD are congruent, right? Because they're both diagonals of this rectangle. They wouldn't tell me that it's a rectangle for no reason. I think that's the reason why they told me, is because diagonals are congruent. Well, notice this. OB, that is a radius, right? And OB and OC are radii. And what do we know about all radii? Well, they're congruent. So if OB is 7, OC's got to be 7. And do you see what's going on? Oh, I see what's going on. If OC is 7, then AD has to be 7. So I know that the length of AD, notice how there's no segment line up top? It's because we're talking about the length, the distance between A and D is 7. Bada boom, bada bing, we're good. Let's recap it just in case you didn't quite get it. We know that this is 7 right here. We added 5 plus 2. 5 plus 2 is still 7. It always has been 7, always will be 7. So when we add those two together, we also notice that OB is a radius. Well, so is OC. OC is a radius, and it also happens to be a diagonal. And since it's diagonal, we know it's congruent to AD, and they are both 7. Whew. Man, that's an exciting problem right there. All right, we have another algebraic type problem here. It's not a proof, which is great, even though sometimes I do like to prove it. All right, so we know that RSTU is a rectangle. So this bad boy right here is a rectangle. I do love rectangles. We want to find RT, so that's one of the diagonals here. If ZT equals x squared minus 1, and UZ equals 3x plus 9. So these aren't the whole diagonals. It's kind of like half the diagonal. Is it exactly half? Why, yes, it is. If you remember back to parallelograms, which rectangles share all the same properties as parallelograms with a couple more, we know that the diagonals bisect each other. And if the diagonals are congruent, like we know in a rectangle, and they bisect each other, their bisected parts are also congruent. So both of these segments right here and here are congruent to each other. So if they're congruent, what can I do? You got that right. You are so smart. We're going to set them equal to each other. Man, how do you guys come up with these things? It's like you've done this before. It's incredible. All right. So I've got those two congruent. When I have an x squared, what are we thinking we need to do? Ooh, how about set it equal to 0 and factor? We got Factor Town coming up. Whoop, whoop. Now that I got it set equal to 0, I got to find two numbers that multiply to -10 and add up to -3. Well, how about -5 and +2? -5 times 2 gives me -10. -5 plus 2 gives me -3. Those are my two numbers. Well, if I solve these, I have x minus 5 equals 0. I get x equals +5. And I have x plus 2 equals 0. So I get x equals -2. Those are my two answers. Do they both work? I don't know. Let's find out. If I plug in 5, I'm going to have 3 times 5 plus 9. Well, 15 plus 9 gives me 24. Okay, that's positive. That's good. The other one, I have to plug in 5, and I square that. Minus 1, I have 25 minus 1 is 24. You know anything that's funnier than 24? 25. All right, so that gives me 24 for each one here. But what's it asking for? It's asking for RT. Well, if this is just half of RT, then I just need to double that, and I end up getting 48. So my answer is 48. But do I have any other answers? Let's find out. One of my answers I know has to be 48. Let's see if that -2 works. Now, usually negatives, they work here and there, but not all the time. But let's definitely check, because sometimes the positive doesn't work either, and it worked here. If I plug in -2, I'm going to have 3 times -2 plus 9. That's -6 plus 9 is +3. That works. And then over here, -2 squared, make sure you put that in parentheses, otherwise you're going to have a bad time. I have 4 minus 1 gives me +3, so that works there. So my other answer for that segment would be 3. And remember, if this is ZT is half of RT, because it's been bisected, the total would be 6 for segment RT. So the length of RT could be 48, or it could be 6 with the information that I've been given here. Yes, you can have two different answers. because of the information that we've been given. It's not specific enough to be one or the other. Either one would work. All right, so we'll be seeing a lot of these where we need to give the most specific name for the quadrilateral, BGHL, and we need to justify our answer. We're going to be graphing these, and a lot of times what we'll need to do is we'll use our slopes. So using slopes is usually one of the easiest ways to tell what type of quadrilateral it is. So let's plot these points, connect the dots, and then let's see if we can justify which one we think it is. Well, here's my lovely quadrilateral BGHL. And now what I want to do first here is I want to find my slopes of each segment. Now, why would I want to find my slopes of each segment, you might be asking? Well, you got to have some kind of purpose, right? We want to have a reason behind why we're trying to do this, and not just find random information that's not going to help us. Well, here's my thought. If I know the slopes, I can prove that these guys are both parallel, and also that these two are parallel. If they're the same slope, I know that they're parallel. That would show that it's a parallelogram, but I could even get more specific and then see if my angles are right angles. I could see if they have opposite reciprocal slopes to show that they're perpendicular, which would mean that they're right angles. So let's find our slopes, and then we can see which type of quadrilateral we have. Well, to find the slope of BG, it's pretty easy. I'm just going up 1 and over 2. That's positive 1/2. And the same goes with LH. I'm going up 1 and over 2. My slope is positive 1/2. The other ones are a little farther away, so I'm going to use the points for those. So for GH, the slope of GH, I have the change in Y, so negative 2 minus 4 over the change in X, 1 minus negative 2. So I'm going to have negative 6 over positive 3, which gives me negative 2 for my slope. So this would be negative 2. And I'll do the same thing for BL. And BL's slope also happens to be negative 2. So what we see here is that same slope here and here, and same slope here and here, so the opposite sides are parallel. And I also have opposite reciprocal slopes, so making these guys perpendicular, which are then right angles. And I have 4 right angles. So I have a rectangle because the slopes make the opposite sides parallel, and they give me 4 right angles. And there we have it. Isn't that exciting? Now what you can do is you can go home and be like, yo, mom, dad, bro, sis, friend, whoever, just somebody, maybe a random person that you just run into at the line at Starbucks. Be like, hey, yo, what's up? Check this out. I can show that this quadrilateral is a rectangle. Maybe even at Walmart. Go to the Walmart greeter and tell them, yo, what's up? Check this out. You want to see something awesome? And you can do that. Man, that's real life math right there. Math in everyday life. And you thought this would never serve a purpose for you. Don't forget about your homework. Now, I know it looks like it might be a bit, but there are 3 different pages because we're jumping around here with these sections, so make sure you get these pages here. And we got our quiz coming up.